Hello students, in this session
Let us solve a question on shear force and bending moment diagram. In a simply supported beam loaded as shown in figure, we have to find the maximum bending moment in Newton meter. So we are given with a beam, simply supported beam is there. This is simply supported at two ends, and the L-shaped load is applied here. You can see here 100 Newton load is applied in terms of a L-shaped system, and due to this there is a direct force as well as bending moment, right? And we have to find out the maximum bending moment in this beam. This we have to find out. We have to choose the right options out of these four choices. So let us solve this problem.
this is a question of shear force and bending moment diagram. We are given with a simply supported beam. This is AB simply supported beam of length 1 meter, 500 mm and 500 mm. We have to find out the maximum bending moment Mmax we have to find out, and we are given with the L-shaped part is there at which 100 Newton load is applied. When this type of load is there, 100 Newton, you can see here what is the reflex action of this 100 Newton, actual effective load of this 100 Newton. This 100 Newton load is acting at point C, this is the one part, and also because it is eccentric, it is eccentric by 100 mm, so there is bending moment in clockwise direction at point C. So it consists of basically two parts. One is the force, direct concentrated load 100 Newton at point C. Another is the bending moment because of eccentricity, which is 100 multiplied by 100 at point C. And the answer is to be found out in Newton meter. So let us convert it into Newton meter so that answer may be easily found out. So how can we solve this question? Let us make another beam of equivalent diagram, equivalent loading. That is a simply supported load. There is some support here, another support is here, and at point C there is two loads. One is 100 Newton load, point load, this 100 Newton, and another is a bending moment due to this load, right? And if I convert it into Newton meter, so this is 0.1 Newton millimeter, so 100 multiplied by 0.1, this is 10 Newton meter. So this is clockwise 10 Newton meter, and this distance, because we have to give the answer in Newton meter, so this distance is 500 mm, means 0.5 meter, and this distance is also 0.5 meter, right? So at point A and B there is reaction. We have to find out that reaction also, RA and RB. This is unknown to us, and by finding RA and RB we can draw the bending moment diagram. And the loading is at the center, 100 Newton direct load and 10 Newton meter couple or moment is there, right? So first find out RA and RB. So let us solve this question. How to find out RA? We can take reaction of all the forces about A. So sum of the force moment of all the forces about A should be equal to 0 because body in static equilibrium. So moment of 100 is 100, and taking clockwise moments to be positive, so 100 multiplied by 0.5, so this is 100 multiplied by 0.5, and this is already clockwise. This 10 Newton meter is already clockwise, so this is 10 Newton meter addition. So this is 100 multiplied by 0.5 plus 10, and RB is anti-clockwise, so minus RB multiplied by total length of the beam is 1 meter, 0.5 plus 0.5, this is 1 meter, that should be equal to 0. So from here we can find out RB. So RB will come out to be 50 plus 10, 60. So this will come out to be 60 Newton. So RB is 60 Newton, right? Kilonewton, 60 kilonewton. This is why it is 60 kilonewton. This is 60 Newton. 60 Newton. 100 Newton or kilonewton? This is 100 Newton. So 60 Newton load is there, right? Now we can find out RA by taking the vertical forces. The sum of all vertical forces should be equal to 0. And there are how many vertical forces are there? 100 Newton is downward and RA and RB are upward. So RA plus RB should be equal to 100. So from here we can find out RA. So RA will be equal to 100 minus 60, that is 40 Newton. So this is 40 Newton and this is 60 Newton. Right? Now we can draw the bending moment diagram. Bending moment diagram. Right? Suppose this is A, C and B. Bending moment diagram can be drawn now. Right? We can take a section at a distance x from one of the end, say from A, we have to take the section. So we can find out mx, and it will be valid from A to C, and that will be equal to force multiplied by the distance, that is 40x, and it is positive, so 40x, right, 40x, and it is valid between A to C. So what is MA? At A point x will be equal to 0, so this will be 0, and at C point x will be equal to 0.5 meters, so this will be 20 Newton meter. So 40 multiplied by 0.5, so this will be 20 Newton meter, right? So this is a linear variation from 0 to 20. So from 0 to 20, say it is 20. So from 0 to 20, this is a linear variation of bending moment, like this. This is 20, right? This value is 20. So at this point, this is 20 Newton meter, right? So from A to C it is drawn. Now we can further take a section at a distance x between C to B. So further we can take a section like this, right, at a distance x. So at a distance x we have taken another section between C to B. So what is bending moment now? Mx, which is valid between C to B, and that will be equal to, there are two forces, rather three, one is 40 and 100 and another is couple, this 10. So anticlockwise is there, 40 multiplied by x, so this is 40x. This is negative because it is anticlockwise, so this is on the left side. So 100 multiplied by x minus 0.5, so this is minus 100 multiplied by x minus 0.5, and another is couple moment 10 Newton meter, this is clockwise, so this is 10. So this is the bending moment, right, and that will be equal to, that will come out to be 40x minus 100x, this is minus 60x, 100 multiplied by 0.5, so this will be 50 plus 50 and plus 10, this is 60. So minus 60x plus 60, this is the bending moment, right? Now it is valid between C to B. So what is bending moment at point C? At point C, where x will be equal to 0.5. Put here 0.5, you will get 30 Newton meter. So solve it, you will get 30 Newton meter. And at point B, where x will be equal to 1 meter at the end, second support, and put here 1 meter, so you will get 60 minus 60, 0. So this will be 0, right? So now at C point there is abrupt change from 20 to 30 Newton meter, right? Because there is a moment or couple at point C, so 10 Newton meter addition is there, so there is abrupt change in bending moment from 20 to 30 at point C, like this, right? And then from C to B, this is point C to B, 30 to 0, and a linear variation, this is a linear variation, so this is 30 to 0, this is a linear variation like this, right? So 20 Newton meter to 30 Newton meter, and then this is 0. So this is the bending moment diagram of this simply supported beam. And you can see here in this diagram the maximum bending moment is this 30 Newton meter is the maximum bending moment. So we can write that Mmax, which is at point C, Mmax which is at point C is 30 Newton meter. So this is the answer of this question, because our aim is to find out the maximum bending moment, max, right? And this is the second option, option B. So option B is correct. Option B is correct.